have the linear system like this. We have equation 1 and equation 2. If you look at this, we have two dependent variable and one independent variable, okay? Two dependent variable x and y, and then one independent variable is t. If we have the equation like this, how do we find the answer of x as a function of t and y as a function of t? It said that if you have the equation like it's called non-homogeneous differential equation, right? But it's coming as the system, okay? A1, A2, A3, A4, B1, B2, B3, B4 are constant. It's not a function of t, it's a constant. So if you have the system like this, you can solve for the differential equation by try to make the equation itself in terms of one dependent variable. And the way that we can do that, we can do by using the Cramer rule from metric. Okay, let's take a look at the example. And then we are going to use this method to find the answer of this type of differential equation. This is, we have two dependent variables, right? But sometimes it's like, it can come like a three dependent variable. The difficulty of this is just depends on like the equation that you have is the first order differential equation or second order differential equation. Now let's take a look at the example. The way to solve for the solution of this type of differential equation, we have to write our system into the term of operator d. Okay. So then we would get 2dx minus 2dy minus 3x is equal to t. Right, for our first equation. And then for our second equation, we can do like this: 2dx plus 2dy plus 3x plus 8y equal to 2. For the first one, the way that we are going to do it is that we are going to put x term with x, y term with y. Okay, so if you take a look at the first one, we have two terms that has x. So we just put them together and then take x out. We would get 2d minus 3x minus 2dy equal to t. And then for our second equation, we do the same. You put x and x together, so you would get 2d plus 3 times x plus 2d plus 8 times y equal to 2. This is our equation 1. I change it to be equation star. This is our second equation, and then I put it as the 2 star. Okay, and then we are going to use the 1 star and 2 star equation to find x and y. Okay, so I just write again. And then we are going to write these two equations in the form of matrix. So the coefficient of x from the first equation is 2d minus 3, and the coefficient of y is minus 2d. For the second equation, the coefficient of x is 2d plus 3, and the coefficient of y is 2d plus 8. Now, if we write out in the term of matrix, we would get something like this. Now, we are going to use the Kramer rule to find x. It's the determinant, right? We put the coefficient on the left-hand side or on the right-hand side of our equation. Replace with the coefficient of x. And then we find the determinant. The way to find the determinant of matrix 2 by 2, you do by multiply 2d plus 8 with t. T is a function, so we are going to put it behind our operator sign. So we would get 2d plus 8 times t. Okay, and you times 2 and minus 2d, which is equal to plus 4d. Two d minus 3 times 2d plus 8 plus 2d times 2d plus 3. This one, you would get what? 4d squared plus 10d minus 24 plus 4d squared plus 60 and on the top we would get 2dt plus 8t 4d. 4d is means 4 times d differentiate the first derivative of 1 by dt, which is equal to 0. This 4d is mean 4 times d1 by dt. d1 by dt is equal to 0. So this term is equal to 0. So on the top we would have only this, okay, which is equal to 1 over 8d squared plus 16d minus 24. 2 dt is equal to 2 times dt by dt. 2. Yeah. Now, if you write this equation, if you write this relation in the term of differential equation, Kramer will give what to us? Give us the differential equation with only one dependent variable. So if we write this one, I would get if you write in the terms of differential equation, you would get something like this. It becomes second order linear differential equation, and it is a non-homogeneous equation. So if you want to find x as the answer of this differential equation, your x is composed of two terms, which is xc and xp. Now if you can write out in this equation, then can you find the answer of this differential equation? Yes, you can, right? To find xc, you got to know the characteristic equation, which is what? 8m squared plus 16m minus 24 equal to 0. We take 8 out. So you find true value of m, which is what? So your m is equal to minus 3 and plus 1. So now your xc is equal to c1 times exponential of minus 3t plus c2 times exponential of t. And then the next step is just find what xp. For xp, if you take a look at the function of your ft, which is equal to 2 plus 8t. 2 plus 8t is in the form of UC function. So the way that you find xp, you can use our first method, which is called undetermined coefficient. Or you can use the operator method, or you can use the variation of parameters. So it's just up to you that which technique that you want to use to find your xp. But for me, I prefer to use the method of operator. Right in the term of I want to use shortcut. Shortcut is the simplest one for me. So I pick shortcut. So if you want to use other techniques, just go do it at your home. That's fine, okay? But now I just want to pick up the shortcut method. So in order to find xp by using the shortcut method, I got to write x in the term of 1 over pd ft. Right, and now I know that my PD is equal to 8d squared plus 16d minus 24. I just take 8 out, okay, from my PD. And then for 2, I want to look at the function of exponential, which is our case 2 for the shortcut method. So I would say that, okay, take 2 out. Like that. And then this one, 8 and 8 cancel out. T is the power, right? So it's our first case of the shortcut method. So the way that we are going to do is we are going to make our 1 over PD in the term of b0 plus b1d plus b2d squared, and so on. But the thing is that now we have this function as a t. So this term, we can do it only the term to the term of d. We do not need to do d squared or d to the power 3. D, that's enough because the rest of the term will be equal to 0. In order to do that, we got to write out the TD in such a way that we are putting the number first. Okay, and then we do dividing of this term in order to get b0 plus b1d plus b2d squared and so on. What's the number that we can use to time with minus 3 and make us get plus 1? Minus 1 over 3, right? Minus 1 over 3 times 3 equal to 1. And then we times again, we got minus 2 over 3d and minus 1 over 3d squared. So what's the number that we are going to time with minus 3 and then we got 2 over 3d? It's going to be minus 2 over 9d, right? Minus 2 over 9d times minus 3, you would get 2 over 3 times d. I don't need to do further more because the rest of the term with the t there, you would get 0, right? So I would say that now my x is equal to, this is our second case. Our a is equal to 0. We are going to put a in every term of t there in our PD. So here if you put 0 there, you would get minus 3. So the answer of this is minus 1 over 12. And this one, we put the term that we just did there